going. All right, good. So last week we sort of introduced the idea of operations research. And operations research is really about making decisions. Making decisions by using data and or models to help inform, describe, make some predictions in order that we can make better decisions, okay? And I'm bringing this up because we're going to kind of move around in this graph tonight. But this graph was taken from another textbook, and it basically says, or it's trying to represent that there's three fundamental things you might want to do with modeling when we're creating models, mathematical models and other things. Two of those are very similar. One called summarizing the data, where you're just wanting to get a summary. You're just trying to figure out overall what kind of information is useful coming out of this data. And the second, which is somewhat like it, is finding hidden relationships. So where you're actually looking for patterns in the data that can teach us something. Something about how the world works, or about where the data came from, or how we could use the data specifically to make predictions about new data. So we might look at one set of data for, say, students in this class that gives us information like their, their GPA, and how many classes they've been taking, or how many classes they're currently taking, so on and so forth, and then whether or not they make an A on the final exam. And say we use that data and try to look for some relationship or pattern in order that we could predict in the future, for future students, whether or not we think they'll get an A on the final based on how similar they are or how different they are to past data for students and whether the past students got an A or not. Okay? So that would be finding hidden relationships, somewhat like summarizing data. Both of those two objectives I would put together to say sometimes what we want to do is basically describe the world, describe how something works, or describe what kind of data we can find, and to find some description of things. Okay, so description is one of the main tools or one of the main reasons we use modeling. The other main reason is the third wheel on this slide, which is to make predictions. So like I was saying about making a prediction of whether a new student would get an A on the final exam, based on patterns we found in past students and whether or not they got A's or not. Okay, so that's combining sort of the description, relationship, pattern finding aspect of the model with making a prediction about future data or making a prediction about future events or future time. Okay, those three basic premises of what you might want to do with modeling sort of breaks down all the different things and tools we can use. We're not going to learn specifically every one of these or examples of every one of these. Specifically, we're going to focus in the first part of tonight with finding hidden relationships. And this idea of grouping, or also called clustering, to basically find from lots of pieces of data to find patterns that we can use to group data together to say this data is similar, and if you are like this data, your outcome will be such and such. And some other piece of data is they're similar to one another. So we can use them to sort of understand how to separate everything into 2 categories, or 3 categories, or 10 categories, or so forth. Okay? We're also going to use some of the same grouping, clustering concepts to make some predictions, to numerically predict what grade you'll get, or to numerically predict other things. By and large, though, tonight, between those two things, what we're going to be focusing on is a concept known as data mining. Okay? And specifically in data mining, there are lots of different algorithms, lots of different approaches, lots of different types of models, let's say, to do data mining. Data mining just involves having lots of data and trying to find patterns within that data. Okay, so we're going to look at specifically 3 algorithms tonight. In your textbook, you'll see chapter 5 describes 6 different algorithms. Okay, once you understand a few basic algorithms, it's not hard to generalize that to more algorithms. Okay, you can learn other algorithms or learn how they work, and they can be used to accomplish the same goal: find patterns, make predictions. Okay, so we're just going to focus on 3 tonight, for brevity of time, okay? And so that's where we're going to start tonight. Now, before we actually talk about the 3 algorithms we're going to use, I want to illustrate a little bit of a problem we might have. Okay, so let's say we have a graph here, and we have data points in this space, such as that. And we're trying to find the pattern to those data. So if this is our x-axis, this is our y-axis, and we think there's some sort of function of x that produces values of y, okay? And we're trying to find from these data points what that function might look like in order that we can maybe predict other values of x, which value of y they have, okay? So one thing we might say is, well, maybe there's just sort of a very linear trend to that data, okay? So the function will look something like that blue line there. It just kind of goes through the middle of all those data points. And the reason why the data points maybe don't match up perfectly with that line is that maybe there's some randomness or some error involved with collecting the value of y, or maybe y is really a function of x and some other things that we don't know about yet, okay? So maybe that's the reason why the points don't line up on the line, but by and large, as x increases, we think y should increase linearly, okay? That's one possible model, one possible function that we could predict. However, in data mining, you'll frequently run into a problem known as overfitting, where given some data points, if we try too hard to find something, some pattern or some function to match that, you might end up with something that looks a little more like this, okay? So that function in red there, there we go, matches the data points a lot better, comes very much closer to them. However, it's a very curvy, it's very unpredictable, and it might be the case that these data points, we didn't really need to fit them perfectly, that the real pattern is much simpler than this red line, but this red line was trying so hard to fit every piece of data that it overfit them. That is, it overcomplicated, created an overcomplicated model or an overcomplicated function of y that fit the data too well, better than it should have. Again, maybe the reason why the data is so far away from this blue line, which may be the real model or the real way they work, is simply because there's errors when we measure the values of y, and sometimes we're off by a little bit, either above or below. Or maybe there's some other variable, z or something else, that influences the value of y, but that this model doesn't know about because we only care about x, okay? So if we try too hard to match the data, we might overfit too complicated of a function to it, okay? That's the problem, and that will be a problem with all data mining algorithms. Technically, you can have that problem in more kinds of modeling than just data mining, but that's specifically a problem that will occur with data mining. And so we need a way to address that problem. We need a way to overcome and know when should we stop making the model more complicated and just accept that it isn't perfect, knowing that no model is going to really be perfect, and there's maybe variables we're not measuring or errors that we just shouldn't bother accounting for, okay? So to avoid overfitting, we're going to use a technique known as partitioning, okay? And this is going to be very important when we talk about all of our data mining algorithms tonight. And what partitioning says is, instead of finding a model to match all the data items, okay, let's put some data items back up there again. Instead of trying to find a pattern that matches all of them, let's take some of those data items and put them in a different set. So I'll separate, say, some of the data to be black and some of it to be red. And then what I'll do is I'll try to find a model that will match only the black data. So maybe I find some kind of model like this. It comes close to most of the black dots. Okay? And what I use the red dots for is to say, when I start making a model that's better on the black dots, but getting worse on the red dots, okay, then I'm starting to overfit. I'm starting to make a model that is too closely aligned to the black dots at the expense of predicting or modeling other data, okay, and I'm overfitting. So by partitioning the data into two sets, one of which you use to make the model, and the other you use to judge how that model's doing. So kind of like a testing set or a training set is what the literature usually calls it. A training set to train the model, and then a validation set to help validate that your model isn't working too hard to match too perfectly the training data at the expense of being correct for other data. Okay? That's partitioning. Partitioning is important to avoid or fix the problem, or not have the problem, I guess I'd say, of overfitting. And that's important for all kinds of models, specifically data mining models. Does that make sense? Okay. So I'm going to show you in Excel in just a minute when we start talking about data mining how we partition the data. And basically we're just going to randomly take all of the data, divide some of it and call it the training set that we build the model with, and the rest of it we'll call the validation set, which we don't use to make the model. We just use that to judge when the model we're making is starting to get too good or better and better on the training set, but worse and worse on the validation set. Okay? And that's when we know the model is too overcomplicated and we should stop. Stop making the model. Stop making it more complicated. It's already as good as it should be. Okay? So that's where we're going. So in order to do that, we need to talk about some of these data mining algorithms we're going to use tonight. The first data mining algorithm we're going to look at tonight is an algorithm known as the k-nearest neighbor algorithm. Okay? And the way k-nearest neighbor works, again, I'm just going to use a simple graph, okay, is let's say we have data that looks like that. That, and maybe some data that looks like that. Okay, so this is some, I don't know, x-axis, some y-axis. And what we're trying to do is say we have a new data item over here, and we're trying to figure out, should that data item be classified as blue, green, or red? Okay? And so you and me, as humans, would visually look at that and say, well, it seems like the blue tend to be sort of down and to the left, maybe the green up in the middle toward the top, and the red on the right. So if I'm going to guess or predict what value an item here would be, it most likely would be red. Makes sense? What k-nearest neighbors does in order to do that is it says, let's look at, say, the k closest values to the value we want to know about. And whatever color, in this case, those k nearest neighbors are, whatever color most of them are, that's what color I'll guess or predict for the new data item. So if we looked at the four closest neighbors to this new data point, we'd see they're all red. And so the k-nearest neighbors algorithm would simply say, more than likely, this should be a red data point. Okay? Similarly, if we had a value down here, and the question is, what color should it be? Again, we'd say, okay, let's look at maybe the four nearest neighbors, 1, 2, 3, and 4. In that case, two of them are red, 2 of them are blue. Okay, so it's half and half, and we would just have to make a guess. Maybe it's blue, maybe it's red, but for sure, we don't think it's probably green. That is, it's not close to any other green data points, but it's close to some red, close to some blue. We'll make some determination. Maybe we'll guess this one is blue. Okay, and so forth. So if we got a data point up here, and we wanted to guess what color it'd be, we'd look at, say, the k closest values, maybe that one, and that one, and say 3 of them are green, 1 of them is blue, majority says this thing is most likely supposed to be green. Okay? That's all the algorithm does. It takes a new data item that you want to predict or classify or guess what value it should be, in this case what color, and says what are the k closest items to it. In this case, I chose 4 neighbors, 4 closest items. The value that you'll choose for k, how many neighbors to look at, is a parameter that you would choose. So when you're building a model based on this algorithm, you would have to choose, do I care about 1 neighbor, 2 neighbors, 10 neighbors, 100? You know, that's a parameter you can choose, okay? And we'll see how we would choose that in Excel in just a minute. Does that algorithm conceptually make sense? Okay, pretty simple. Let's look how that would work. Okay, so I'm going to look at a database. This is a Excel spreadsheet that came out of the textbook for chapter 6. There we go. And what this spreadsheet is interested in showing is, like we talked about last week, the columns here are different fields, and the rows are different records, that is, different data items. In this case, what we're trying to represent are people who are applying for credit. So they're applying to get a loan that they'll pay back later, right? So they're like a credit card or something like that. And so we've recorded different fields, different aspects of all the people who've applied for credit. So every row or record is a person who's applied for credit, and the fields here are different attributes of those people. So some of them involve the duration of how long in months they want a loan for. Some of these other things involve whether or not they're trying to get a loan to buy furniture or a car or what they're going to buy with their loan, okay? And so on and so forth. Some of these, I think, involve the gender of the person. Some of them involve the amount of the loan that they're trying to get, so number of dollars or whatever it is, and so forth. At the end of this spreadsheet, what we're most interested in the last field or last column here is the response, which is a 1 or a 0, where a 1 is somebody who we thought had good enough credit that we gave them a loan, and a 0 is somebody who was denied credit. That is, we didn't give them the loan for one reason or another. So this is a record of a lot of people who've applied for loans in the past and whether or not they got a loan or not. Okay? What we're going to do is we're going to use a data mining algorithm to find out, is there a pattern in this data, a relationship that would say a person of some particular age or trying to get a loan of a particular kind to buy something or a particular amount, we either would give them a loan or not give them a loan in general. So trying to find general patterns to the data. In this case, we're going to use the k-nearest neighbor algorithm. Okay? Now, the way k-nearest neighbor works, remember, is it has to find which values are close to the one we're trying to predict, or close to the one we want to know about. So you might ask, in this case, how do we figure out which records are close to, or most similar to, a particular other record that we care about? And we're going to do that by simply taking the difference between the two records across all these different fields. So whether or not they're trying to get a loan for furniture versus a car, that's a difference. Whether or not they're trying to get a loan for 48 months or 24 months, that's a difference, right? So how many differences there could be between two records will help us judge which records are similar, that is near, to other records or not, okay? Now, remember, if we're going to build a data mining model, this k-nearest neighbor, the idea is we're going to find the right value of k in this case for building a model that can correctly predict whether or not somebody gets a loan or not based on their similarity to k other records in this database. Okay? So the parameter, the thing we can choose, is the k. So our goal here is to find the best value of k, number of neighbors, that would produce the best model. Okay? And again, to avoid the problem of overfitting, we're going to divide the data into two parts. A training set, on which we will build a model for different values of k, k1, k of 2, k of 3, building that model. And then we'll use that training set data to help predict the credit worthiness, let's say, of all the data in the validation set. Okay? And we'll judge how many of the data in the validation set did we get correct. Did we correctly predict either a 1 or a 0, they got credit, or they got the loan, or they didn't. Okay? And we'll use that validation set to judge how good of a model we had for different values of k. So again, we're going to take every row from the validation set, find the k nearest or k most similar rows from the training set, see whether or not most of them got credit or most of them didn't, and use that as our prediction for that record in the validation set. We'll do that for every record in the validation set and judge what percentage of them we got correct, what percentage we got wrong. Then we'll do that for another value of k. 1k, k2, k3, k4, 5, 6, and figure out which value of k got us the lowest percentage error on our validation set. Okay? And that's how we'll use the k nearest neighbor data mining algorithm to find the best value of k for this particular data set for predicting whether somebody gets credit or not. Make sense? Okay? All right, I'm going to walk you through the steps for that. Hopefully you've installed the Analytic Solver platform software. If not, there are instructions on Blackboard for how to do that. You have to be careful and be sure you input the correct codes for this course and for the textbook and Oklahoma Christian University and so forth, so that you get a license to run this software for 140 days. Otherwise, you'll just get a trial license for something like 15 days, okay? So, which won't be long enough. Okay, so if you go in Excel, if you have Analytic Solver platform installed, you'll see the Excel Miner platform tab, okay? For some reason, I have my buttons disabled. Desktop. Computer seems very slow tonight. Through, okay? So the first thing we need to do is partition the data. That is, randomly select some of these records to be the training set and some of them to be the validation set, okay? And the XML, or the XM Miner platform has a tool for doing that. So we'll just click a few buttons, tell it to randomly partition, and it'll do that for us, okay? And what it'll do is it'll take this sheet of data and create a new data sheet down here at the bottom with the data broken into those two subsets for us, okay? And mark one of them training and one of them validation. From there, all we really have to do in this case is select a few options from the XM Miner platform to say we want to run the k nearest neighbor data mining algorithm to build a model using that algorithm for predicting the validation set records, whether or not they got credit or not, based on all the training set records, okay? And it'll do that work for us. So apparently I hadn't activated. Maybe that was my problem.